welcome back to the Compaq Portable Restoration Part 2. Now, just as a refresher as to what happened in the last episode, I had problems with the motherboard, and the video card, and the RAM, and the floppy drive, and the keyboard. And I managed to get most of the problems squared away internally. So the first thing I want to tackle is getting this keyboard working. So beyond just cleaning up and retrobrighting the keys, I also need to replace all these pads, which we talked about. And the entire case needs to be cleaned, and there's some other little internal modifications I want to do as well. So let's get started. I'm actually not sure what color these are actually supposed to be originally. But when I compare with the case plastics, it just seems to be like perhaps the keys are a bit yellowed. And they do need to be cleaned anyway, so I'm going to go ahead and take them all off. So I'm going to use the key puller. Now, when pulling a key off of a keyboard that I've never pulled a key off before, I don't know if, I might end up breaking it. So I'm going to pick a key that I don't care that much about. So I'll start with this one. That way, if I have to glue it back on or something, it won't be a big deal. And it looks like it came off pretty easily. Alright, so a few notes about springs. You might wonder why I'm putting the springs in here, and I'm putting the keys in there. Well, the thing is, I want to make sure that I have something I can close up when I'm done, because these springs, if they get lost or fall on the floor, they're almost impossible to find. The other thing I want to warn you about is that while these two springs here look pretty darn similar, this one here is for the space bar, and this one here is just for a regular key. And you have to make sure to keep these separated, because the space bar, it has a lot stronger springiness to it. It's a lot stiffer because it has a bigger key to move up. So you don't want to get these mixed up. So I always store the space bar one separately. And while this is not terribly dirty, it does definitely warrant some cleaning. Some Windex should clean this up easily. Also, check this out. A bunch of those original pads just fell off during this process. Here's a close-up of one of the keys, and I just wanted to give you an idea of how dirty they are. They aren't by any stretch the worst I've seen, not even close, but definitely still need some cleaning. And here's what it looks like after cleaning. And I wanted to show something else. In cleaning these, I noticed particularly with this sort of key that has this extra bit on it, if you flip it over, you can actually see the original color of these keys on the bottom. So yeah, they're definitely yellowed. As always, this process is tedious. I expect to spend an hour or so cleaning all of the keys individually like this. I recommend you just turn on some of your favorite music to help pass the time. I need to Retrobright these, but this is the current conditions outside, and it's forecast to stay this way for a few more days. So I won't be doing any Retrobright outdoors. That being the case, I'll use the stove. Now, I need to mention a few things about this. Temperature is very important here. You need to get the water somewhere between 130 and 140 degrees Fahrenheit. If you're lower than that, it won't work very well, but if you're higher than that, it can melt the plastic. And I've already had some angry emails from people who boiled their keys, which in turn melted them, and then they were angry at me for suggesting it. So just to set the record straight, I never said to boil the keys. So once we have the right temperature, I'll go ahead and pour the keys in there, and then I'll add some peroxide. Now, people always ask how much to use, and there is no set amount. If you use less, it'll just take longer, so don't worry about a specific amount. So I'll check the temperature again. It's gone down because I added the cold peroxide in there. But what I'm going to do is set a 5-minute timer to remind me to come back in here and check on this. And so every 5 minutes, I'm going to test the temperature and adjust the controls as needed to keep it in the sweet spot. After 4 or 5 times, you'll get the temperature stable enough that you can let it sit for longer periods without checking on it. So while waiting on that, I'm going to turn my attention to these plastic pieces. Now, while they don't need Retrobright, they are dirty. And sometimes it's really hard to see it on camera, so I'll give you some close-ups. And this is definitely going to be a job for baking soda. And these little feet look the worst. And here's what it looks like all done. And I'll try to give you a close-up comparison with the computer case, which is still dirty, so hopefully you get the idea. The next thing I'm going to do is remove what's left of these old pads. Now, I found this little tool to be very helpful.
You may notice that the foam is so degraded that the pieces just pull apart real easily, but I have to get the whole thing out of there, so I need to get underneath it. And there we go. All removed. Okay, so the keys have been cooking for about 2 hours, so I think they're probably done. I'll just pour out the water and the peroxide. Then I'll rinse it out a few times with regular water to make sure all the peroxide is gone. And for those inevitable comments about rinsing a hot pan with cold water, keep in mind there's only about 30 degrees difference in the temperature of the water in the pan, since I didn't heat it up to boiling. And I'll leave these here to dry. Now, I want to talk a little about these pads and how they work. They are made of essentially 3 parts, and you have a spongy foam in the middle, and then a rigid plastic piece on top. This is the part that actually snaps into the key and holds the pad in place. On the bottom, you have a conductive material. And when I say conductive material, I should really clarify how that works. Even this part is another little sandwich, with a conductive coating on one side and a non-conductive layer of mylar on the bottom. And you see, these keyboards are actually capacitive in design, so they actually have more in common with your tablet or smartphone in that they detect capacitance. And that's why I was able to type on the bare PCB using my fingers in the last episode. So when this little layer is pressed up against the pads on the board, it creates a very small capacitor, and that's what lets it know that the keys are pressed. And so that's how these things work. So I ordered some materials I thought I could use to make my own new pads, starting with this foam. Now I'll need to cut a smaller section out, and then I'm going to use this emergency blanket for the capacitive layer, and I'll cut a similar sized piece of this. The next thing I need to do is get this blanket pulled tight so that it'll be flat. And I think taping it to the table will accomplish that decently well. There we go. That seems to work. I'm going to add an extra layer around it because I'll be using spray adhesive and I don't want it on my workbench. So the idea is I'm going to glue this piece of foam to the blanket, and then I'll use one of these stencil sheets to create that rigid layer on the top. So it'll go like this. Okay, so I'm going to try this particular spray adhesive. I've never used it before, so I have no idea how well it will or won't work. Okay, here goes the foam. It seems it's sort of tacky already, so that's sort of a good sign. Here's some more adhesive. And then here's the final piece of the sandwich. I'll set something heavy on here while it dries. Skipping ahead about 8 hours, this stuff should be dry, and I'll remove the tape. And here we go. This is our little sandwich. And I bought this hole punch of the correct size. I think it's meant for leather, but I think it'll work. I don't want to damage my workbench, so I'll put this piece of scrap aluminum down here. And I'll just pick a random spot and see what happens. I'll need to push these out of there with a screwdriver. Okay, so here are my first 2 test pieces, and immediately I can see the adhesive simply didn't work.
Okay, so apparently the adhesive I used is simply not going to be suitable for bonding these 2 types of materials. Actually, it looked like it did a little bit better job bonding the plastic to the foam than it did the mylar. So, I actually ordered all this stuff before I completed the last video on this Compaq. I actually wanted to give it a shot and see if I could make it work, and while I could probably find some other adhesives that eventually make this work, there's actually not much point, because you see, after I released the video, the guys from Texelec sent me this nifty little box of stuff here.
Kevin saw my last video, and apparently he sells these pads already pre-made. And I had already Googled for such a thing before I started this project and didn't find it, so I'm glad he contacted me about it. These look pretty well made. He also sent me some other parts that may or may not be related here. This is apparently for the PC Junior adapter boards he made and sent me a while back. And this will be helpful. It's a 1 megabyte RAM board that will work in most any XT class machine to get you up to 1 megabyte of RAM. You can set the dip switches to determine which banks you need turned on. Okay, I'm going to go ahead and start installing these pads. Unfortunately, you can't just press them in like this, which I was hoping you could do. There are 4 little clips on each key, as you can see here. And what you'll have to do is take a little pointy tool like this and make sure that the plastic circle pops into place under each of those 4 clips. And this is going to take a while. I think I spent an hour or so putting all of these in. So again, you might as well get some music going and be prepared to take the time to do these. And here it is finished with all the pads in place. Okay, so I'm about to put the keys back on, and of course I took a picture of the keyboard before I took the keys off. And I'll tell you right now, I made a mistake, and I did some of this out of order, and I'll explain, and you'll see what I'm talking about a bit later. I can certainly see the retrobrighting helped with the color of the keys. Remember this transistor here? It might be a power regulator. I didn't look at the other side. Anyway, if you recall, that actually screws on here, and there was some thermal grease in the middle. And so I'll go ahead and put some new transistor grease on this one and spread it around a bit. Now we can put that back on here, and then I'll put the screw back in place. And as you can see, I have put back the bajillion little screws on the bottom of the board. Now, here's where things got really annoying. When I went to test the keyboard, the internal floppy drive had quit working again. So I borrowed one from my Tandy, and I set it on top until I had time to mess with the internal drive again. Anyway, the drive worked, but the keyboard, not so much. Literally only a handful of keys actually worked, so I had to take it back apart again. Looking at it, I found a few pads that were probably not installed properly, including the spacebar, which was protruding a lot. I also noticed the main chip in there had some corrosion down one of the pins, so I cleaned that off, but that shouldn't keep so many keys from not working. So I took one of the pads and just went across all the keys and tested each one, and essentially every key worked, so I knew there was nothing electrically wrong with the keyboard. I put it back together and tried again, and then I decided to start marking off all the keys that didn't work in an attempt to find some sort of rhyme or reason. And here we go. Of course, I couldn't test the function keys at this point, but most keys were not working. It was at this point I noticed there was a lot of small gunk, including fingerprints and most also dirt and other debris stuck to these pads, and at this point I realized most of this gunk had been picked up from a workbench, which was still somewhat dirty when I started putting the keys back on earlier. That's because every time I pressed one of these keys onto the keyboard, it was pressing the pads up against the workbench. And if you were to take a look at the cross-section of the pad as it contacts the PCB, and if you were to zoom in really close, it should look like this. However, when there's even a small amount of debris, it will create a gap like this. And so if it were a conductive system, it wouldn't matter, but having an uneven surface disrupts the capacitance. So I cleaned the bottom of every pad with alcohol, and I also cleaned the PCB itself. I also used some canned air to maybe get anything I missed. And after that, it was down to this. Granted, not perfect, but much better. I just replaced those pads with some spares I had, and that pretty much got everything working again, as you can see here. In fact, now I finally had enough keys working to run the Check It program, which has a handy key testing system where I could finally test every single key. And it works. It was at this point I still had a few issues with the disk drive, and the motherboard wasn't recognizing all of the RAM. Kevin from TechSelect did come over and offer to help repair some of that, and he actually did end up taking the stepper motor out of the disk drive and even replacing some more capacitors on the motherboard. And unfortunately I didn't get any video footage of that, but we were able to get everything working, including it now detects the full 640K of RAM on the motherboard. I also installed the XT IDE interface and mounted the Compaq flash reader in one of the card slots on the side. And this worked out perfect because with the card fully installed, the side door will actually close. And then I was able to format the drive for my DOS boot disk. By this point, I had cleaned the keyboard and the two removable panels, and even on video here, you can clearly see a contrast between those and the places I haven't cleaned yet. I had done all of this cleaning with wet baking soda, and it was very effective. And as for the string on top, I determined that it was just decorative and didn't actually hold the handle together in any way, so I just decided to pull it out and cut it off at the ends. And here it is, all done. It looks immaculate, almost brand new. Time to test it out. You know, the CGA graphics doesn't actually look that bad on this screen. In many ways, it looks better on a monochrome screen because you get 4 shades of gray, or in this case, 4 shades of green. And I think that's probably better than the magenta and cyan. I apologize about the angle of recording on the screen. I didn't realize it was this bad until editing. Of course, being this thing is 4.77 megahertz, It can only run maybe 10% of MS-DOS games, mostly the games that came out in the 1980s. However, it can run Planet X3, and it runs just fine. And so that finally wraps up the restoration on this computer. Now, I hope to bring you a documentary on this thing pretty soon, in the next couple of months, because I think this computer has a really fascinating history, which I look forward to bringing to you. I also want to give out a big thanks to Kevin from Texelec, as well as DJ and Raymond, all of whom helped repair this computer in some way or another. And by the way, if it weren't obvious, this has been one of the more challenging restoration projects that I've taken on. Now, I don't know if all of these machines will be as difficult to get working as this one was, but I certainly wouldn't recommend one of these as your first-time restoration project. Anyway, that's about it for the moment, so stick around for what's coming up next, and thanks for watching.